Okay, hey everybody, this is DW, and what I'd like to do is go through the problems that I signed yesterday. And sorry, this is a little late in the day. I had meant to do this morning, but I've been having a lot of trouble with the software, and it took me till now to get the software up and running so I could make this video especially for you. Okay, so this is the page that I assigned, and you may have noticed that what I put here is a little bit different than what is in the video. It looks different, but it's actually the same. And what I'm going to do is go through two different ways of writing out this chain of calculations to show you that it's actually the same thing. So we're given a problem here, and technical difficulty. I don't know why the arrow didn't come out, so that's supposed to be an arrow. Let's go through the first problem. And remember, you cannot work without a balanced equation, and we have our coefficients already given to you. And the problem is giving 25 grams of ethene and asking for a mass of oxygen. So we have 25 grams of this stuff, and we want to find out how much oxygen will react with that, what mass of oxygen will react with that. So let's leave the 25 grams up here. And we're going to write the 25 grams down here, and that's C2H6. Now, this map tells us to divide by the molar mass. So we get the molar mass from the periodic table. We can see that C2H6, we have 2 carbons and 6 hydrogens, and that adds up to a molar mass of 30. So we're going to divide by 30 grams. And then we're going to multiply by the coefficient. So A is the amount that you're starting with, C2H6 in this case. B is the amount that you want to get to, which is oxygen. And so we want to multiply. We're in this box right now. So we're going to multiply by the coefficient of oxygen, which is what we want to get to. And so that is 7. So 7 oxygens, and then what we already have, is C2H6, and the coefficient is 2, so we have 2. So that's 7 over 2. And then here it says to multiply by the molar mass. So the multiply by the molar mass of B, B is oxygen. So A is what you're starting with, C2H6. And B is what you want to end up with, oxygen. So the molar mass of oxygen is 16 plus 16, which is 32. So we're going to multiply by 32 grams. And I believe that gets us to 93.3 grams, I think. And that is 93.3 grams of oxygen. Okay. Let me get my calculator just to make sure. Okay, so 93.3 grams is correct. Okay, so previously going from mass to moles, you were told to multiply by 1 mole divided by the molar mass. I hope you can see this is actually this exact same thing. And I'm going to write it out the way we were doing it before. So we're putting up here what we're given in the problem, 25 grams of C2H6, and that's over 1. And then now we would go to the next box 1 mole divided by the molar mass, 30 grams. And now the next box, which is the coefficient of B over A, so 7O2 divided by 2C2H6. And finally, previously we were given that this was the molar mass over 1 mole. And so if we do molar mass, 32 grams of oxygen for every 1 mole, I hope you can see that this is the exact same calculation that we had before, which is that you're multiplying across, so 25 times 7 times 32 divided by 30. And that is exactly what we did up here. And we get same answer, 93.3 grams of O2. So I thought, and I hope I'm not wrong, that if I just give you a simple divide by molar mass or multiply by molar mass, that might make these calculations a little bit more straightforward. So let's see what happens with the next problem. Now we're given an amount of carbon dioxide that we want produced and asked what mass of oxygen will we need for that amount of 50 grams, that amount of CO2 to be produced. So I'll do it both ways. So we'll call this method A, and we'll call this method B. So using method A, we have 50 grams of CO2. Then we're asked to divide by the molar mass. So molar mass of carbon dioxide is 44 grams. And then multiplying by the coefficient of B over A. B in this case, so A is CO2, that's what we're starting with, and B is what we want to get, oxygen, so O2. And then we look at the coefficients, and the 7 is for oxygen and 4 is for CO2. So 7 oxygen, 4 CO2, and then we multiply by the molar mass of oxygen, which is 32 grams. All right, let me quickly plug that into my calculator. We get 63.6 grams of oxygen. So let's do it the second way. And I hope you can see that the second way is really the same as the first, setting it up in a slightly different form. So here, 50 grams of CO2. And then we have that over 1 times 1 mole over the molar mass, and then times the coefficient ratio. That's from the balanced equation, the coefficients, and then times the molar mass of oxygen per mole. And that gives us a grand total of the exact same amount. So if we look at what we're doing here, it's 50 times 7 times 32 divided by 44 times 4. That equals 63.6. I realized I forgot to put the times 2 over here. So sorry for that mistake. All right. So you're multiplying everything on top and then dividing by what's on bottom, 44 times 4. So you need to put these in parentheses, and that gives you your answer. So what I'd like to do, so please don't hesitate to email me any feedback regarding what you're seeing here. I'm going to give you 2 more problems to do. Hopefully this has helped. If not, again, email me, let me know what's going on. All right, so using this exact same equation, I'm not changing anything we have other than just in terms of the equation that you need and the coefficients. Ask how much water is produced from the combustion of, could you give me a number?
5.
5? Like, I need a bigger, like point something.
5.3.
Thank you. 5.3 grams of C2H6. Okay, so that's problem number 3. And then problem number 4, how much water in mass? So I forgot to put mass. So here, what mass? Any number?
12.7.
12.7. Okay, reacts with 12.7 grams of oxygen. Okay, so if you could do those 2 problems for tomorrow, and what's today, Thursday?
I think so. Yeah, it's Thursday.
Okay, and we will reconvene tomorrow. Okay, I'm going to I'd like to have a meeting on Monday, a Zoom. Zoom, is that what they call it?
Yeah.
Yeah, a Zoom thing where we all get together and laugh and make merry and have lots of fun just talking at each other and learning stoichiometry. Okay, do these 2 problems. Test yourself. Work your brain. Good brain exercise. Bye.